Hello, welcome to my course about Python Getting Started. In this video, I will give you an overview of the Python programming language. I will guide you through the installation of the Python interpreter and show you some Python language features, the syntax and its capabilities. First of all, this course doesn't assume any specific programming experience, but a basic understanding of functions and program execution can be helpful. Python is a widely used high-level programming language developed in the late 1980s. It places strong emphasis on code readability and simplicity, making it possible for developers to start application development easily. If you are new to programming, Python is the best place to start. Programs in Python require considerable fewer lines of code compared to other high-level programming languages like Java or C++. Python is also cross-language. The same code written for one operating system, such as Windows, which we'll demonstrate in the next minutes, will work exactly the same on other operating systems like Linux or macOS. We will be talking about the following topics in this course. First of all, we will see why we should use Python. Um, we will also see how to install Python. Then we will see how to write some first commands into the Python shell. Um, we'll go over to variables and operators, data types, see what conditions are and how to iterate over a series of items. Next, we'll see what functions are and how to create our own modules, and also see how to work with files. Python is a high-level programming language, and like all high-level programming languages, Python code resembles the English language, which computers are unable to understand. That's why we need a special interpreter, which we can download from the Python site. The Python interpreter has to be installed before we can code, test, and execute our Python programs. We'll look at how to install the Python interpreter in the next minutes. High-level programming languages like Python are very similar to one another. Examples are C#, Java, C++. Learning one such language helps us easily learn other languages because the syntax is very similar. What differs is mainly some difference in syntax and the libraries which are available, and also the way we access those libraries. Python is also highly portable across operating systems. We will demonstrate code written in Python using Windows, but this code will the same work on macOS or Linux. In this video, I will be using the Windows installer. The Python Windows installer can be downloaded from python.org/downloads. If we open this link, we will get to this website. And here we have the download Python button. In my case, I will download the Windows version, but if you are on another operating system, please download your version. Clicking this button will download the installer. Once download is finished, please click on it and install it. I have already installed it on my system, so I don't need to install it again. Also, the version might be newer if you are watching this video in a later time. But after installation is finished, we will have different options for opening the Python shell. One option is to use the idle program. This is a program which comes with the Python installation. If you search for it in the taskbar, in the Windows search, you will get this Python program. Just click here idle and you will see it. Here I have the idle with the Python 3.6. Once this is open, it will look like this. So here, for example, you can right away type Python commands and they will be executed by this Python interpreter, this Python shell. Another way is to use the command, a command prompt. Just open a command prompt and type here. So here you are in the command prompt, and to switch to the Python interpreter, if it's installed, we can here type Python, and this will switch to the Python shell. So here we can then again start writing Python commands. Good. We can do the same thing also from PowerShell. Type here, we're checking here PowerShell window, just open PowerShell. It's the same like a command window, but PowerShell I like that its visual appearance is a bit nicer. Good. I will zoom a bit in to be able to see the commands I write here. And here are you now ready to write our first Python commands. Okay, we're starting. Once this is opened, switch here again to the Python shell, so to the Python interpreter, and here the lines start with these three arrows are the commands you should type, while the lines after the commands show the results. So for example, we type here a command, let's say 5 plus 8, and this returns us the result. This is very clever, so it interprets our commands and executes them. We can also type other type of commands like checking if a value is greater than another value. This is true, so 4 is greater than 3. We can also write 4 less than 3, let's see, and this is obviously false. We can also use some Python commands. So for example, let's use the print method. So this is a function basically. So we'll see how to define also our own function, but for demonstration purposes, this is just a built-in function of Python, which should print some string we put in here. So for example, hello world. This will just right away print what we entered. Good. We can also declare variables, more on variables later, but again, for demonstration, we can declare a variable x equals to 5. This will store this number into memory. And to retrieve this value, we issue the command x, which simply will retrieve the value and displays it. What I want to say about this Python shell, it's very convenient tool for testing Python commands, especially when we are first getting started with the language. It's good for learning. The downside is that if we exit from this Python shell, all the commands we have just typed, they will be gone. And basically we cannot really create an actual program. To code an actual program, we need to write the code in a text file and save it with the .py extension. So this is a Python file. It's basically a Python script, and we will cover this Python scripts and modules in the next modules. We can also we should basically download the Python IDE, so to be able to easily write Python modules. It's much more easier. For example, on my PC I have installed Visual Studio Code. This can be downloaded from this location. In order to download it, please navigate to this code.visualstudio.com. It has installers, as we see here, also from macOS or Linux. I will download the Windows installer. Actually, I have already downloaded and installed it. So it will look like this. The nice thing is that we see here very nice these identifiers, the predefined keywords we see with colors highlighting. It's much more easier to write code in this way than in a standard, for example, a notepad where we don't have this highlighting. So please also download the Visual Studio Code for your operating system and install it. Also, after installing Visual Studio Code, I would recommend to also install some extensions. So if you open here the Visual Studio Code, you will see here somewhere we have the files, and below we have the extensions tab. And here, please type for Python. Search for Python, and here we have some tools. I have already installed them, and this helps us to highlight the Python code to have some useful coloring. Also, the indentation is done automatically, so I would recommend this also. Next, we're going to talk about variables. So now that we have an overview of how Python works, let's check what variables are. Variables are names given to data that we need to store and manipulate in our programs. For instance, suppose your program needs to store the name of a user or a number or some text. To do that, we can name this data my number or first text, and using this syntax. So we have the equals sign, and here we have the name of the variable, and here we have the value we have to assign to that variable. After you define the variable, your program will allocate a certain area of your computer storage space of your memory to store this data. You can then access and modify this data by referring to it by its name, my number or first text. Every time you declare a new variable, you need to give it an initial value. In this example, we gave it the value 5 or hello. We can always change this value in our program later. Let's open a shell window and see how this works. So for example, we have equals 5. Then we can retrieve it, and this will be displayed on the console. We can also declare two variables. Let's say we have a variable x and one y, and this equals 5, and I will give here a string for y for the second variable. Good. So retrieving x is 5, retrieving y is text. Regarding variable naming, variable name in Python can only contain letters, numbers or underscores, but the first character cannot be a number. This is contrary to other programming language like Java or C# where we can do this. So for example, I can declare variables like uh, whatever, my name 2, I have 1 equals 4, but I cannot declare 2 my name, for example. I will get here an error. Also, variable names are case sensitive. So for example, my name equals 4, my name. So the casing is here different. So my name with big N and small, and this is 5. You will see here the difference. So these are basically two different variables. Is 4 and my name is 5. Yeah. Camel case. This is basically camel casing. Yeah, it's the practice of writing compound words with mixed casing, like we saw here with my name. This is the convention that I use in this video. Another option is to use lowercase this underscore to separate words, but this is not so commonly used. I haven't declared it, that's why I get this error. Now we'll first look at some basic data types in Python, specifically the integer, float, and string. Finally, we'll discuss also some more advanced data types for lists and collections. Integers are numbers with no decimal parts, whereas float, you see we have here a decimal part. Integer can be positive and negative. To declare an integer, we simply declare a variable. Let's see in the following example. For example, x equals -5. Retrieving it gives us the value back. Also, we floats have decimal places. We can declare a float y equals 1.23. Retrieving it delivers us the value. Another commonly used data type is the string. For example, string refers to text. To declare a string, you can either use a variable, my string, I will use here camel casing, hello, this is okay, retrieving it delivers us hello. We can also declare a string with single quotes. This is also fine. We can get a string, we get it back. We can just not combine single quotes and double quotes. Python also includes a number of built-in functions to manipulate strings. So function is basically a block of reusable code that performs a certain task. So we have the built-in functions in Python. For example, we have the upper method, which is included in Python by default. We can call my string dot upper, and you see all the chars from the string are converted uh, from lowercase to uppercase. Next, we're gonna see another data type, the list. A list refers to a collection of data which are normally related. So, for example, first of all, I want to clear the screen to be more visible. So for this, we have to import a module. And from this OS, we call the os.system, this function, which CLS. This basically clears the screen. Probably there are other ways to do it, but yeah, I found this way of doing it currently. To declare a list, you have to write the variable name, my list, and we have to declare here a list of values. 3, 4, 5. We can declare also strings in it, so this is not strongly typed as opposed to other programming language like C# where all the elements from the list should be of the same type. Individual values in the list are accessible by their indexes. We can, once declared, we can get the first element. So this retrieves as the first element. This is 0 index based. Yeah, they start from 0, not from 1. This is a common practice in almost all programming languages, such as C or Java. So the first value has the index of 0, the next has the index of 1, and so forth. So we can also assign different value to this index. So we can give it another value. Yeah, let's assign a different value, new value. We give it a string. And now we can print the list to see. You see here that this has updated, so the first element is not 3 anymore, it's new value. Yeah, so you can also access values of a list from the back. So the last item in the list has an index of -1. So let's just access this value. We'll see we get the last value from this string here. So -2 get us the value before the last value, and so on. To remove items from the list, we can simply type del from delete. So my list, we get here the index, for example, the index, we want to delete the first item, and just getting back the list, we see we deleted the first element. To append items to this list, to add new items, we can use the append method. So mylist.append, and here we can append another string, last element, call this, and you see we appended this item on the end. Another data type for storing collection of data is the dictionary. A dictionary is a collection of related data pairs. For example, if you want to store the username and age of a couple of users, we can store them in a dictionary. Yeah, for example, to declare a dictionary, we can write dictionary equals. We have to declare them in such brackets, and here we declare key value pair. So for example, a name and a value, 38. We declare another name, Anna is 21 years old, and this is a dictionary. To display the values, just type dictionary, and you see we get the values back. We can also access values based on the key, dictionary. You can see how old is Dan. I misspelled here, 38, right? Yeah, to modify items in a dictionary, we can use similarly. Dictionary, then we can here give it another age. Let's see, 55. And now display all the values from the dictionary. You see that the value of Dan has updated to 55. Okay. We can also remove items from this dictionary. Again, we use the del keyword, and yeah, we specify which value we want to delete. I want to delete this user, and you see now we have only one element in the list. Good. To add a new element to the dictionary, we just have to declare the new key, dictionary. Let's say Peter equals 43. Okay, I misspelled the dictionary again. And you see we added this key to the end. So this was the dictionary, and these were basically the most commonly used data types in Python. Next, we'll look on how to make choices and decisions in Python. we'll be able to make our program smarter, capable of making choices and decisions. First, we will look at the assignment operator. Then we look also at some basic arithmetic operators like plus, minus, modulo. Also, we'll check some conditional operators, less than, greater than, if it's different. And also we'll be looking at the if statement, the for loop, and the while loop. These are known as control flow tools. They control the flow of the program. And before we go into these control flow tools, we have to first look at the assignment operator. In programming, the equal sign is known as the assignment sign. It means we are assigning the value on the right side of the equal sign. We are assigning this string value Dan to the variable on the left side. So my name gets the value of Dan. So for example, I will open a shell, a Python shell, and we can demonstrate that. For example, let's say we have two variables, xy equals 5, 6. We are able to perform addition operations. For example, x plus y is 11. Subtractions, y minus 5 equals 1. Also multiplication, for example, x multiplied by y is 30. The division, y divided by x is 1.2. It's a floating number with decimal places. We can also perform floor division. So y by x floor division. This rounds down to the nearest whole number. Also, we can perform modulus. So x uh, this is the modulo sign. It gives the reminder when 6 is divided by 5, and also the exponent sign. So x exponent y is a big number, actually, is x to the power of y. Besides the equal sign, there are a few more assignment operators in Python. This includes operators like plus equals. So for example, x plus equals y, and we check the value of x. This is 11. So this is a shorthand for writing x equals. This is the same as writing x equals x plus y. Good. Um, so for example, we have these relational operators. For example, we test for equality with the double equals operator, and we test for inequality with this exclamation sign and equals. Um, we can also compare values with this less sign, greater sign, less or equal or greater than equal. The most common condition statement is the comparison operator. If we want to compare whether two variables are the same, we use the double equals sign. For example, if we write here x equals to y, this returns false because yeah, these are obviously not equal, and x is different to y. This returns true because they are not equal. We can also check if, for example, direct. We can check also values. This is
greater than 2, and you can also check that 5 greater or equal than 5. This will return true because one of these signs here is true. So 5 is equal to 5. Good. These are the relational operators. Good. Next, we're gonna look at conditional statements, namely the if statement. We're starting with the if statement. Before that, I want to switch to Visual Studio Code. I showed you how to install Visual Studio Code at the beginning of this video. Navigate to that section. You can check the description where to install Visual Studio Code. And after this is installed, you can execute these commands to open Visual Studio Code. So first of all, I need a folder where I create my Python modules and scripts and files, which will be executed. So this if statement, I will execute them from I will create some Python files and will not execute them directly in the Python interpreter. Good. Navigate to a folder on your hard drive where you want to create your scripts. For here, you can open Visual Studio Code and navigate to this folder, but you can do it also like this. You can open a command line, and from here you can type code dot, and this will open the Visual Studio Code for you in this folder. Nice. So here you see I have opened Visual Studio Code. Um, yeah, please check that you have this Python extension installed. This is very useful when working with Python scripts. Python, let's check again if it's installed on my machine. So at least this Python extension should be installed, is very useful. And also this if you're doing some more advanced stuff. Good, coming back. Um, Here we will create the Python scripts. Let's switch to the if statement now. Okay, here it is. So the if statement is one of the most commonly used control flow statements. It basically allows our program to evaluate if a certain condition is met and perform the appropriate action. So if this expression is true, it executes this block. If not, it will execute here the second block. Uh, Here you see we don't have these curly braces, as this was the case in other high-level programming language like Java or C Sharp. Instead, we use here a space. So this is basically here for spaces or a tab. This is the convention in Python. If you don't have 4 spaces, you will get an error on execution. Good. Um, let's show this in a Python file and show how this if statement behaves. I will open again Visual Studio Code, and here we can start writing our first Python conditional statement. For this, I will have to create a new file. I will name it, I've clicked here the plus sign, and here I will name it conditionals.py. So this tells us it's a Python file. You see here also the icon updated. And here we can write our first conditional statement. Let's check if a variable has a specific value or not. Let's declare a variable. Let's call it my name equals Dan. And here we'll check if yeah, basically we do a simple check. We we use this conditional operator. If this name is Dan, then we print. Um, I have to put a colon. you see if I press enter, it enters into this condition body, which means it puts here at the beginning exactly 4 spaces. I can also type four times the space, 1, 2, 3, 4. You see exactly the place where the Visual Studio Code uh, moved the cursor. So it's a very useful tool. If you would have not used such an editor, you have to all the time put the spaces yourself. So let's use the built-in function from Python. You will see here we get also some suggestions from this Python extension. And here we just print hi Dan. And now we have written our first conditional statement, our first Python file, and let's execute it. Yeah, we have to save it anytime. If we're not save it, these last changes are not visible. Let's open a terminal. For this, we have to open a terminal. Yeah, it's basically a PowerShell window. And here, how to execute this file. So make sure you're in the same folder as your Python file, and then we can simply type Python conditionals.py, and you see here here is the output. So for example, we checked if the name is Dan, and we just print that hi Dan. If we would have given it another value, let's see if we now print something. Python, you see we don't print anything because this condition is not met. Uh, Good. Let's check um, another common use case. So we have the if statement and we have also the else statement. So what happens if if this condition is not met? Then we can simply print um, else. So we just execute this else clause if the first if is not met. We print here. We get also autocomplete. Just hi, we just say hi, just update again this value, save it, execute again. You see, so this name is not Dan, then we go on the else case. uh, Good. Let's check another condition. We have also the elif uh, elif case. Let's say that we want to check if elif name equals, let's say, Paul. We have this intermediate. Oh, I put this semicolon. So we just have to put this. Okay, and now we can write here print hi Paul. We get some customized messages. So this means the Python uh, interpreter will just interpret this, will check if one of the values is matching. So if this is true, then print Dan. If the second one is true, then print Paul. And for all other strings, we print just hi. Let's check if we get on this path. You see, we had here hi Paul. So this is, we can put any number of elif. Good. So this was the if statement, and yeah, I talked about this significant white space. This is how Python uh, organizes these blocks. It's much more, it's not a lot of code. We don't have this extra spacing with semicolons, starting, ending. It's very clear and makes the code more readable. Next, we're going to talk about loops, specifically the while loop and afterwards the for loop. Like the name suggests, a while loop repeatedly executes instructions inside the loop while a certain conditions remain valid. It looks like this. We have the while expression, so we check if this expression is true, then it evaluates, it executes this block of code. Most of the time when using a while loop, we need to first declare a variable to function as a loop counter. So let's demonstrate this in Visual Studio Code. So this is the if statement. We will create here a new file and call it while loop.py. So this is the file. And now we as I said, when using this while loop, we have basically to create a condition. So I will create here, for example, a variable, let's say counter equals 5. And we have the while loop, while counter greater than 0, let's say, colon. And now we have the, the function, the body. We just print this number. So print counter equals, so basically good. And to not have an infinite loop, we have to basically decrement this. We have this autocomplete counter equals counter -1. Yeah, let's save it with Control S or file save. And now we execute this while Python. Here we have this other file while loop.py. You see, we execute all 5 times. So we decrement the counter until the value is 0. Then basically this condition here above is not met. Means that the while loop ends and the Python executor will continue after this while loop, but this is basically finished. Good. Next, we look at the for loop. So the for loop executes a block of code repeatedly until the condition in the for statement is no longer valid. Uh, the syntax is as follows. So for we get the first value in this iterable, then we execute this block. Second, we take the second value until it ends. To demonstrate this, I'll open again the Visual Studio Code, and here we will create a new new file for this file for loop.py. Now we will declare here a list, as we saw previous how to declare lists, a list of, yeah, let's say we declare here a list of all um, of months, and let's say this is a list of January. We get basically the first 3, February and March. And for this one, we want to iterate over them with such a for loop. The statement is like this. So for month in months, get here autocomplete. We can navigate and press tab. And here with uh, colon. And now we have the for body. And similar as the while loop, we print we print the the month. Yeah, we get basically the first month from here and iterate over all months and print the month here. Good, save it. Now again, uh, Python for loop dot py. You see, we get all these months displayed here. Next, we look at two interesting control flow statements. These are very useful in case of for loops or while loops. And what does this doing? So the break statement, when working with loops, sometimes you want to exit the entire loop when a certain condition is met. To do this, we use the break keyword. Let's check that in Visual Studio. So inside the for loop, so for example, we want to exit in a certain case this loop. Let's say if the current month over which we are iterating is, for example, if this is February, then we put here a break, save it, and let's see what happens. You see, if the month, the current month when we are iterating is February, we exit the loop. So with break, we execute only the code until this break statement is reached. And in that case, we exit the loop and continue immediately with the line after the for loop. Another interesting uh, keyword is this continue. With this one, is similar to break, but this will just ignore the current month. So for example, if we put here continue, this means it will check if this is met and will skip this iteration and will jump uh, directly to the next month. So let's just save it and execute this again. You see, we print only January and March, so we're not directly exiting the for loop with continue. We're just skipping this case where this condition is met, and we're executing the next iteration. Now we're looking at functions. So functions are simply pre-written code that perform a certain task. For instance, we can use the built-in function print, as we saw earlier, for displaying text on the screen. This simply works like typing print, and in the we just say it what to print out. We can define also our own functions in Python and reuse them throughout the program. Here we see the statement is as follows. So we have this def keyword. It tells the program that the intended code from the next line onwards is part of the function. So return is the keyword that we use to return an answer from the function. There can be more than one return statement in a function, but once the function executes a return statement, the function will exit. So also, if your function does not need to return any value, you can omit the return statement also. Um, Also, the code inside of such a function has to be indented with 4 spaces or a tab. Um, and now we can also demonstrate how to create such a function. Let's just switch over to Visual Studio Code. Yeah. And let's say we have this code in the if, but we want to create a function from this one. Yeah. Let's say we create here a file, first function. UI. And here we use this syntax as we showed here. So for example, def display name. This is the name of the function, and we can get here also a parameter, yeah, or display greeting better, because we will display a greeting based on the parameter. Though this is the name is the input parameter. Display name, display greeting. Sorry, greeting. Um, we put in a colon, and you see we get a nice indentation. And inside this function, we can put here, for example, this if logic we have written previously. We have to format here a bit the indentation. So all this which is under this def function is part of the function body. Now we have to save it, and now we have to execute this. To let's switch to the terminal. We can clear the terminal to not have so many uh, text here with the CLS in Windows. And now let's just uh, see how to use this function here. To call this function, we just have to call it somewhere. So let's after we declare the function, so after the function definition, let's call it. So we have here a call to display greeting, yeah. And here we have to provide the parameter. Let's say we provide here Dan. So this is a call to the function. So when the program execution reaches this line, it will basically call this function here with the parameter Dan. Let's save it. And here we can again Python first function dot py, yeah? And you see we get here the output of this method call. If we put here something else, Paul, save it, run it again, and everything else. So this will just display high. Now we will be talking about modules. First of all, Python comes with a large number of built-in functions, and these functions are saved in files known as modules. To use the built-in codes in Python modules, we have to import them into our programs first with the import keyword. Uh, we saw already that we create modules with files ending with the py extension. We have these built-in modules, and we also can create our custom modules. We will demonstrate this in Visual Studio Code, how to create a module and import it. Let's say we have this first function.py. This is basically a module. It's a Python file which creates a definition of a method. Um, let's say we create here new module.py. Here we can basically import this. We can import here the function to use it. So we're in this new module. We write the import keyword, and here we see what was the name. So first function.py. You see we get IntelliSense, so first function. And now from here we have access to the functions defined in this module. So for example, what was the name? Display greeting. This, let's call it like this, yeah. Let's put this method here, the function here. And here we get is not defined, it says. First function. We should get access here to this. We have to, okay, yeah. We have to fully qualify the function name with the module name here. Now we save it, and we are now able to call this new module py, which imports the first function. Let's type again Python new module .py. We can type here some text and press tab. This will auto complete it. You see, we get here, this is called 2 times. Why is this happening? Because our first function which we're importing already did this method call. This will display. To illustrate that, let's just put here a valid value to get into this elif, save it, and now we execute again. You see we get high poll. This is executed here, and afterwards we we execute also this function, which will just display high because of this string. Good, but normally you in such a model you will not call methods. You just have the methods, and these are available to to the the file which uses them. Let's save it, and now we see we get only this message from here. We can also import specific function. We can just, for example, just get this name, import from display greeting. Is it working like this? So how's the syntax? Let's see if we get here a suggestion. Yeah, I think it's the other way around. So you have to type here from. Yeah, you have to start with from. First function, import display greeting. So this is, we don't get here any errors anymore. And now we don't have to qualify it with also with the module name. So let's execute it again. And you see it works also like this. Good. Uh, what I want to mention is about Python comments. So this one are some comments. They are useful in documenting code. It's basically these lines of code are ignored by the Python interpreter. So we have two ways of doing it. We can prefix them with this hash sign, or on multi-lines we can put here 3 single or double quotes ending with the same style. And these are basically for documenting. So switch over to Visual Studio Code to see how to document it. For example, if we want to document what this method does, we can put here displays greeting. This is not very useful. Normally in clean coding, the function name should be self-explanatory, but just for demonstration. So saving this, so this will not affect the function behavior. We can also have multi-line. You see, we have to end it somewhere. So everything in between is treated as a comment. Again, execute it, so this is not taken into consideration. Good, enough about comments. I want to talk also about a bit about variable scope. So we saw what variables are, and we have in Python we have local variables and global variables, and in most programming languages. Uh, I will demonstrate here an example. Yeah, basically the variables defined inside a function are treated differently from variables defined outside of the functions. Any variable declared inside the function is only accessible within the function, and these are known as local variables. And any variable declared outside the function is known as a global variable and is available, accessible anywhere in the program. Let's see an example. We have here the name parameter. So basically, we can define here another name. Let's say name equals Andrea. This is basically here a global variable, and let's see what happens. We will also add here a case for Andrea to be clear. Let's format the indenting. So we have here the name. Let's see which name is taken into consideration. The name from here or from here is saved. So you see we don't get here the global variable. We use the name provided through the method parameter. We can also redeclare here things. It's maybe clearer to say it's not a useful case, not a usual case to do this, because that's why we have the parameter. Well, here we can see the difference. So we declared the name, redeclared it to Dan, execute it. You see hi Dan because we have overwritten this parameter name, but here you see when we're inside of this function, we use the local variable, not the global from here. Global variables are useful when we have multiple methods which uses the same name or the same to not repeat ourselves in the program with the same variables. Now we'll see how to work with text files in Python. So basically Python makes it very easy for us to work with text files. We have to write just a bit of code in order to be able to read from text files, write to text files, and perform different operations on text files. We will see how to read from text files and how to write to text files in the next minutes. Switching back to Visual Studio, we will create here first a text file to read some lines from it. We'll create basically a text file. I will call it text file.txt, and we will put some 2 lines of code. First line, second line, yeah. Good, this will be our text. We'll save it, and now we'll create a new Python file which is able to read this text file and display it into the Python terminal. We will call this file operations.py, and here we declare a variable which opens a text file. So here we have the open function. This is a built-in Python function, and this one gets as a parameter the file name. So we enter here the text file we just created, text file.txt, and we need to provide also a text mode. So open text mode. Here we will see next all the modes we can open files, but here we want to just read text from it. Now, in order to read all, we can read the lines individually, but we can also do a for each to print all the lines from this text file. Let's say we want to iterate over all lines. For line, we get each line,
And here we provide the loop body, and we just want to print out the line text. So line, uh, and we will also, yeah, just print them. And at the end, uh, we exit the for loop. We have to close the to dispose this resource. Basically, the file handler is a resource, and we have to dispose, to not lock the file for other applications, for example. Now we will save this. Let's see. So I will here write Python and file. We can write this and press tab. We see we get this auto completion, and you see we get here the first line and the second line displayed. Good. Okay, that was reading from a text file. Let's see how we can yeah, first of all, let's see this file access mode specifier. So we have this R for read mode. We have the write for writing only. So if the specified file does not exist, it will be created. And if it exists, any existing data will be erased. That's why we can also the append mode. So this means if the specified file does not exist, it will be created. And if it exists, any data written to the file is added to the end of the file. And we have also the R plus uh, indicator. This means we can open the file for both reading and writing. Means we can here provide different access specifiers. So here we should give the least permissions possible because of security reasons. Good. Uh, Now let's see how to write to text files. Uh, so we have this file already, the text file txt, and now we want to create a Python script which adds some contents to this file. We create here a new file operations, right, to differentiate them. Here again we have this f equals open. Okay, we use the same text file dot txt. We give here the text mode we want to append, so we will append here some text to this file, and this is very simple. We just have to use this write function. Um, Here we append some text. We can use the new line to write this on the new line. This text, yeah, we use third text, and we can write as many statements as we want, but at the end we have to close to dispose this resource. Good. Let's let's check this text file as it is at the beginning. So we have the first line and the second line. And now we want to execute this write operation to write the third text into this text file. So again, Python uh, and file operations, right, okay, good. It executed. Now we go and check the contents of the text file. You see we inserted the third text here. Good. So this was reading and writing. Uh, Besides that, we have other file operations. We have the rename and the remove. Let's see how this works. So the rename basically gets the old file name and renames it to this new file name, and the remove simply deletes this text file. Let's see how this works. So we want to create a script here for renaming this, but we also can get here into Python mode, I guess. Yeah, and we can execute these commands directly here. We don't have to create a new Python file explicitly. So let's see how this works. So we are now in the same folder where the text file is, and we want to make sure we rename this file. First of all, rename. We specified the old file name, so it's text file.txt, and the new file name. Uh, so, and here we write new text file name. Good. Enter. Okay. It's written here we don't have access to this. We, of course, we need to do something else here. So we need to have a file. So similarly like this, we need to do it like this. So uh, let's just call here. We need to open this text file. Let's just give it read-write operations. It's safer for having the right permission when renaming. And now we can do the same. So I will use the previous method, f.rename. Let's see if this works. Seems that we get some errors. Yeah, we will see how to handle exceptions and errors in the next minutes. But now, basically, this doesn't work because we need to import a module in order to work. We have the OS module. For this, we have to import this module to have access to these rename and delete functions. Okay, and now we have to use that module. So we have to use os dot rename. So look at this text file, the name we had before, and now after executing this, we don't have permissions, yeah? We don't have permissions to access this file. Let's try to close this file from here, and now try again. Okay, this also doesn't work, so it seems that something is holding us for performing this operation. Let's see if we open a new terminal. Maybe this we we have to just close that file that we opened earlier. Let's see now. Okay, this worked. You see, we had the file handle, and this blocked us from renaming. But now I have disposed this file handle, and now the new text file is renamed. And finally, we can also delete. So os.rename. Delete. Yeah, remove basically. So this is the method for removing files. Here, new text file name dot txt. Let's see. Have I written it bad? Let's see. New text file name. So I haven't provided here on renaming the file, the new file extension. I will delete the txt. It does not have an extension. And you see it disappeared from here. Good. So we saw a lot of errors here. And yeah, next I want to show you how to handle errors. So coming back the to the presentation. So basically we saw here how to delete and rename files. We have to import this OS module and how to handle exceptions. So we have these statements, the try and except. In the try block we do some logic, and in case of some errors, unexpected errors, we have this except statement which catches all these errors. So It's the same like in other high-level languages where we have the try catch, but this syntax is with try except. Good. Let's see how this works. Previously, we have written some file operations which attempt to open a text file with read mode and print all the lines. Let's try to execute this again. So we saw earlier that we deleted this text file, and we want now to execute again this code. So we write Python. Uh, yeah, we basically we we entering the Python shell, and we want to execute from here these Python modules. Python, also VXC should work, and here file operations. You see, we get here an exception. It says file not found error. So we try to read some text from this text file txt, but this doesn't exist in the current folder. One way to handle this, we can use here a try catch or a try except basically. So we have this try logic. We do f, and here for each line we do some indentation. And in case we don't have access to this, okay, so the indentation was wrong, a bit like this. And if we get an exception, what we want to do is, in all cases, we want to close the file, and also we want to print a message in case something went bad. Error accessing file, yeah, this is basically a message, but normally we can do some logging also on different things here. Good, let's save it and execute it again. So okay, so f is not defined, so basically we even don't come to this case because the f here is not initialized and we don't have access to it. So basically we have to write here, just put f here in order to so like this. Save it, and again we get this error message which we provided here in the except clause. Good. We have different error types. So if I have input output errors, for example, when this file does not exist. We have import errors when there are errors importing modules, permission error, index error when we try to access, for example, dictionaries with an index which is too high, indentation error, name errors, type errors. There are a lot of errors here. Here basically there is a link. Um, yeah, we'll just open it. Let's see, I will show you this link with all the exceptions. Um, yeah, this is the link basically. docs.python.org, version 3, library exceptions. Here we see all possible exceptions. We have also base exception, and there are a lot of them. We arrived at the end of the course. In this video I show you why we should use Python. I showed you how to install Python and execute our first commands into the Python shell. We covered variables, operators, and data types. I showed you also how to use conditions and iterations. We also saw some built-in functions and how to create our own functions in modules. And also we saw how to work with text files. If you like this video, please subscribe to my channel, and I invite you to view also my other videos.